All right, and let's get into this third part. These are the remaining questions from that first packet that I skipped over. So we're jumping right up here into number 12. So number 12 here says that we want to determine the following information. They give us quite a few things here we want to fill in for each of these rational functions. These were those things that had the vertical and the horizontal asymptotes and all those little pieces that we want to worry about. So honestly, before I even do any of this, the first thing I think I need to do over here is I need to factor this and figure out what it's going to end up looking like. So when I'm taking a look at this, I know the top part, or the numerator here, is going to factor. I need two numbers that multiply to make -2 and add up to make -1. So I think we're going to end up with x minus 2 and x plus 1. -2 times 1 is -2, and add that up, I get -1. And in that denominator, I see a difference of 2 squares. That x squared minus 1 tells me I'm going to have x plus the square root of 1, which is 1, and x minus square root of 1, which is 1. And we can see these x minus 1s get to cancel out here. So overall, I have x minus 2 over x minus 1. So that is my simplified version. So let's take a look at these actual questions they're asking us. For part A, they said, does the function contain the point 3, 2? So what that's asking us to do then is take that function and plug 3 in. So I've got 3 minus 2 on top over 3 minus 1 on the bottom. 3 minus 2 is 1. 3 minus 1 is 2. And that equals 1/2, which does not equal 2. So for part A, no, the function does not contain the solution 3, 2. B says find the vertical asymptotes. Remember, that is done using the simplified version. And all we're doing is just looking at the denominator here and seeing what would make that equal to 0. So in this case, I have x minus 1 equals 0. Work that out, we get x equals positive 1. So that is my vertical asymptote at positive 1. Identifying the holes or the removable discontinuities, which is what they'll probably say on your test, removable discontinuities. That's done by looking at what we canceled. So in this case, I can see that I canceled those x plus 1s. That tells me that the x value of our hole is -1. What this would equal if we set it equal to 0. So x plus 1 equals 0 would give us -1. But I also need to take that and plug it in to the final solution to figure out what we're going to get for the y value. So I'm going to do that right here in a different color. -1 minus 2 over -1 minus 1. Again, all I did was plug it into that formula right there. I take this -1 and plug it in up into that formula. And when I do that, -1 minus 2 is -3. -1 minus another 1 is -2. And overall, that gives us a positive 3/2. So I know my solution comes out to -1 3/2. That is the hole or the removable discontinuity. D said identify all the horizontal asymptotes. Horizontal asymptotes are the ones that we use the rules. Remember, we said if the numerator is bigger than the denominator, there is no horizontal asymptote. If the denominator is bigger than the numerator, the denominator is bigger, then we have 0. Y equals 0 as our horizontal. And if they end up being the same power, which is what happens here, these two things both have an exponent of 2. So since they both have an exponent of 2, we just divide the leading coefficients. So y equals 1 from right here, divided by 1 from right here. And 1 divided by 1 is 1. So y equals 1 is our horizontal asymptote. In fact, I'm going to write that here correctly. There we go. E says identify all the zeros. Zeros come from our numerator. We look at the numerator and set that equal to 0. In this case, our zeros are just x equals positive 2 because we would set this equal to 0 and we'd add 2 to the other side. So we would get x equals positive 2. And finally, we've got identify the y-intercept. The y-intercept, if you recall, is there you look at these two little constants at the end, and then that would give you your answer. So what we're going to do is we're going to write it as 0 for the x. And if I plug in 0, I would get -2 on top and -1 on the bottom. Again, all I'm doing is looking at those two numbers, -2, -1. Well, overall, we know that that would simplify to 0, and -2 divided by -1 is positive 2. So 0, positive 2 is our y-intercept. And there's all 6 of those pieces. Looking at number 13, it says find the slant asymptote. So this is one of those situations where the numerator's exponent is bigger. If the numerator has bigger exponent than the denominator, we have no horizontal asymptote. But if that denominator is less by exactly 1 power, we could have a slant asymptote. So in this case, you can see my numerator is exactly 1 bigger in power than the denominator, so we do have a slant asymptote. And we find that one of two ways. We can either use synthetic division, or we can use long division. So one of those things. In this case, we know it's not synthetic. Synthetic only works if the denominator is like x minus 1 or x plus 2, something simple like that. In this case, though, we've got this really ugly thing on the bottom, so we know that we're going to have to use long division. So on the outside, we're going to put what's going divided. So in this case, what's on the denominator? So x squared minus 5x plus 6. And divided by, and on the inside, we're going to put what's on the numerator, x cubed. But there's a couple extra pieces. I want to make sure that I include the 0x squared, the 0x, and then we can put our minus 8. So I'm making sure to include all the terms, including the things that aren't written there. And then remember what we're doing in this case is we're looking at this and we're saying, what do I have to multiply x squared by to get to x cubed? Well, I know I'm going to have to multiply by x. And then you take this x and multiply it to all three things in front here. So I'm going to have x times x squared. X times x squared is x cubed. X times negative 5 is negative 5x squared. And you can see now that these placeholders are really useful. And x times 6 is 6x. And then the question wants us to subtract this. So ultimately, I'm going to distribute this negative. And this becomes negative x cubed, positive 5x squared, and negative 6x. Cancels here. 0x squared plus 5x squared is 5x squared. 0x minus 6x is negative 6x. And we'll bring down this negative 8. Again, what do I have to multiply this x squared by to get to 5x squared? Okay, I know I'm going to have to multiply by 5 here. So we're going to put up top right here. We're going to put plus 5. And again, we're going to multiply. 5 times x squared is 5x squared. 5 times negative 5x is negative 25x. And 5 times 6 is positive 30. Remembering that this becomes a subtraction problem. So to distribute, we got negative 5x squared, positive, what number did I write there? 15, nope, 25. 25x, that's ugly, I'm sorry. And then negative 30, so these cancel. Negative 6x plus 25x is 19x. Negative 8 and negative 30 is negative 38. To be honest with you, we honestly don't really even care about that though, because this remainder right here is irrelevant. All we care about for our answer is whatever we got right here. In this case, the slant asymptote is y equals x plus 5. In fact, when you're doing these problems, as soon as you get to this step, you could stop. You didn't really need to do any of this here because we know that we're not going to worry about the remainder when it comes to doing slant asymptote. All right, 14 asks us to solve this inequality. Well, the first thing I know I'm going to have to do is you can't work with inequalities that are greater than or less than numbers other than 0. So I know that this 1 is going to get moved over. We're going to subtract 1 from both sides. The problem is that's going to create something ugly because you can't subtract 1 from a fraction right away. It ends up being 6 over x plus 3 minus 1 is greater than or equal to 0. So that's your first step, is just to get it set up like that. And ultimately, I need to make sure that this turns into a fraction with common terms. So I'm going to move this over. And what I need to do is I need to get this negative 1 to have the same denominator. So we have it over 1. I need to have the same denominator as the first fraction. So I know I'm going to multiply by x plus 3 on the denominator and in the numerator, because that will make them overall the same thing. So I've got 6 over x plus 3 minus, and in the top we got x plus 3 over x plus 3. Again, noting that if I put those together, x plus 3 divided by x plus 3, we get 1 again. So it didn't really change the problem. But now I can actually set this up and solve this problem. So now I can rewrite it as one fraction over x plus 3. And I've got 6 minus, I'm going to keep this in parentheses for now, 6 minus x plus 3 is greater than 0. And the reason I'm going to keep it in parentheses, we have to make sure that we now take that negative and distribute it in here. So this becomes negative x and this becomes negative 3. So I've got 6 minus x minus 3 over x plus 3. It's greater than or equal to 0, which leaves us with just one more step that can be written. We can put negative x, negative 3, and 6 makes positive 3 over x plus 3 is greater than or equal to 0. So we did these a little bit where we talk about identifying key points. We focus more on this doing domain, but it's still the same idea. What we do is we start by looking in the numerator. What could I plug in for x that would make this equal 0? What would make that a key point? So I'm going to put negative x plus 3 equals 0. So ultimately we know we'll subtract 3. We get x equals negative 3. And negative x equals negative 3 means positive x equals positive 3. That's my first key point. And then we'll look at the denominator, x plus 3. I want to figure out when that equals 0. So I would subtract 3. I get x equals negative 3. And that's my other key point. All right, what we're going to do now is create a timeline, or a timeline. A number line is what I meant to say. Ooh, I'm sorry. We want to create a number line here. So I want a number line that has these two key points on it. So I've got a key point at negative 3 and at positive 3. And what I'm going to do is I'm going to go back to this problem right here, and I'm just going to plug these numbers in and see what happens. So if you plug in something smaller than negative 3, like negative 10, let's see what happens. I'm going back over here. Plug in negative 10 here. So negative 10 plus 3 is negative 7. 6 divided by negative 7. Is that greater than positive 1? Well, no, it's not going to be. In fact, actually, let's not do it there. Let's do it here. I think this makes more sense. Let's plug it in right here. Okay, so I plug in negative 10. On top, negative 10 plus 3 is negative 7. I'm going to write that underneath here, negative 7. And again, I'm just picking a random number that was less than negative 3. You could pick negative 9, negative 5, negative 4. It doesn't matter. I picked negative 10. Negative 10 plus 3 is also negative 7. I screwed that up. Y'all, I am sorry. Let's try that one more time. If I plug in negative 10 on top, negative 10 makes positive 10. Positive 10 plus 3 is 13. And then negative 10 plus 3 on the bottom is negative 7. Is that greater than 0? Well, no, it's negative. So in fact, I'm going to write negative right here because I want to address that that's going to be a negative number. From negative 3 to 3, when I plug in, let's plug in 0. When I plug in 0, I get positive 3 over positive 3, which gives me positive 1. So it is positive here. And if I plug in a large number, like again, 10, we'll do positive 10 this time. Positive 10 on top is negative 10 plus 3, which is negative 7. Positive 10 on the bottom is 13, so I get a negative number. So we know that in order for this to be greater than 0, the only place where that's going to happen is right there in the middle where it's positive. So I know this space is the only space it'll happen. But I also know a couple things. Go back and look at the original problem. If I plug negative 3 in, negative 3 on the bottom is going to make the bottom equal 0 because it's negative 3 plus 3, and that is not allowed. So I know that my problem is not allowed to equal negative 3. So we'll put a parenthesis there. But for positive 3, if I plug that into the original one, I get 3 plus 3 is 6, and 6 over 6 is 1, and it's allowed to be equal to 1. So this will be a bracket. So my final answer is negative 3, comma, positive 3 with a bracket. All right, coming down to this next piece here. We have two problems right here kind of clumped together. So 15 says, convert each angle from degrees to radians. So in order to convert from degrees to radians, remember we multiply by pi over 180 and then simplify. So in this case, I'm going to multiply by pi over 180. And I get 225 pi over 180. Now you are allowed to use your calculator. This is considered a calculator question. So I hope that you are comfortable using your calculator to do fractions. If not, for the TIs, you would just type in 225 divided by 180, and then you'll press math, press enter on fraction, and press enter again. And I get 5/4. So I know this is 5 pi over 4. For this one here, I've got times pi over 180, and I get negative 49 pi over 180. 49 and 180, though, do not simplify with each other, so that is going to be the final answer. Negative 49 pi divided by 180. And taking a look at this next one, I got 655 on top. So 655 times pi over 180. I end up with 655 pi over 180. That first step's always nice and simple. 655 divided by 180 on my calculator gives me the decimal 3.638. And we'll go math, fraction, enter. And I get 131 pi over 36. And my last one here, negative 15. So we're going to times pi over 180. I get negative 15 pi over 180. And those should each divide by 15. So I end up with negative pi over 12. All right, and jumping over here, we got 16. It's a little bit of a weird one here. These two go together, but then 16's over here on the right side. We're going to do the same thing, but we want to convert into degrees. So instead of multiplying by pi over 180, we're doing the opposite, multiplying by 180 over pi. And this very much is just typing in your calculator and getting the right answer. So when I multiply here by 180 over pi, the pi's cancel, and so now I have 5 over 6 times 180, and that's all I'm literally doing. I'm typing into my calculator 5 divided by 6 times 180, and I get 150 degrees. Right here, we're going to multiply by 180 over pi. Pi's cancel. 13 divided by 4 times 180, and I get 585 degrees. In this one, we multiply by 180 over pi. Those pi's cancel. 5 divided by 3 times 180. And I get 300 degrees for that one. And one last one here. We're going to do times 180 over pi. Cancel those pi's. In this case, I've got 7 divided by 2, or negative 7 divided by 2, times 180. And I get negative 630 degrees. All right, on to 17. It says determine one positive and one negative coterminal for each of the following. And then I gave you 4 degrees and 4 radians to practice on. So make sure you do all 8 of those. But we're going to just do this here with just these 2 and 2. So in order to determine one positive and one negative, remember it's always about adding or subtracting one full rotation, which in terms of degrees is adding or subtracting 360. So all we're going to do here is take 150 and add 360 to it. And if I do that, I get 510 degrees. And then we'll do the same thing, take 150, but subtract 360 this time. And when I do that, I get negative 210 degrees. So there's one positive and one negative. Now, this one's a little bit weird because it's negative 740. So I know I'm going to need to add 360 to it to get it somewhere closer to a positive. So I'm going to start with that. Take that negative 740 and add 360 to it, and I get negative 380. So there's one of my negative ones, but I need to get to a positive one. The problem is if I add 360 again, I'm only at negative 20, and they wanted me to find one positive one. So I'm going to need to add another 360. So I'm going to add 360 one more time. Negative 20 plus 360 is 340. So the way I'll write this is negative 380 plus 360 plus 360. And when I do, I get 340 degrees. All right, for these radian ones, they're a little bit trickier because you have to add or subtract 2 pi. But they're already written as fractions, so you need to rewrite them as fractions with the same denominator. So when I go to add 2 pi here, I actually have to redo this problem and do it 3 pi over 7 plus, and I need something over 7. So in other words, if this is over 1, I'm multiplying the top and the bottom by 7. So 1 times 7, 7. But 2 pi times 7 is 14 pi. So 3 pi plus 14 pi is 17 pi, and then keep the 7 on the bottom. And there's my positive version. And now that we found that number, it's kind of easy. We do 3 pi over 7, but we subtract 14 pi over 7. And I get negative 11 pi over 7. Notice the denominator is staying the same. That's not changing. All right, now I got negative 19 pi over 4, so we're going to add 2 pi. So I need to multiply by 4 and multiply by 4. So I get negative 19 pi over 4 plus 8 pi over 4, which is going to be negative 11 pi over 4. That's still negative. In fact, when I do this one, it's going to be another one of those situations where when I add 8 pi over 4, that still only gives me a negative number. I'm still at negative 3, so I'm going to have to add 8 pi over 4 again. And now that's going to be negative 3 pi over 4 plus another 8 pi is positive 5 pi over 4. So we have our positive and our negative now. All right, and for 18, it says for each, find the arc length and then find the area of the sector. So we've got this one that says a circle formed has a radius of 3 and a central angle of 137 degrees. So what we need to remember is that for our formula, the first one asks us to find the arc length. That formula is L equals theta times R. Super easy formula, but theta has to be in radians. And our problem does not have it in radians. So we need to make that conversion first. So 137 degrees multiplied by pi over 180 to do our conversion. 137 divided by 180. I don't know if that simplifies. Let's find out. It does not. We just end up with 137 pi over 180. So now I know what theta is. I'm going to plug that into this formula over here. This L equals theta R. So theta is 137 pi over 180 multiplied by the radius R, which is 3. And so we're just going to multiply that by 3 and multiply it by pi in our calculator. So 137 times pi divided by 180 multiplied by 3. We get 7.17. I'm going to keep the units we had up there, feet. Well, B asked something similar, but B asked us to find the sector area. So the formula we have here is that area equals 1/2 theta times r squared. So very similar problem, except we're using r squared and 1/2 this time. So theta is still going to be the same thing, right? We still know theta is 137 pi over 180. And we're going to multiply that by 1/2. And we're also going to multiply it by the radius squared, which is 3 squared. So we got 137 times pi divided by 180 for the middle part. And I get 2.39. And then I'm going to multiply that by 1/2 and multiply it by 3 squared, which is 9. And I get 10.759. So 10.76 is what we'll put. I don't know why this part doesn't want to work. 76. And this time we got feet squared because we're talking about area. And that brings us to the end of this first part that I was supposed to finish a while ago. Hopefully that all makes sense to you. Let me know if you have any questions.